Hello, class. Let's take a look at how we can hedge the return of a portfolio. And in particular, we're looking at hedging and under the Black-Scholes Merton framework here. Now, when you are trying to hedge the return of a portfolio, typically there are a few characteristics that are important. If you have a portfolio and you want to control the characteristics of this portfolio, the movement or the return of this portfolio, you may, for example, want the return of the portfolio to be insensitive to market movements. Now, you might have heard the terms alpha return versus beta return. Alpha return is related to the return of a portfolio that is independent of general market movements. And beta return is really the return that is directly related to the movement of the market. It's typically fairly easy and inexpensive to generate beta return, but creating positive alpha return or large positive alpha return is typically very difficult and sometimes costly, and that's why alpha returns are usually rewarded. So people want to have somewhat delta neutrality as part of the investment portfolio. Now, the other characteristic that people would like to have is what we call gamma positive. Gamma positive really means that if the underlying price were to change, either positive or negative, then the portfolio value will always increase. So it's like a curvature, which I see a graph later on. But gamma positive means that there's a curvature such that no matter which direction underlying asset is moving, the portfolio value itself is always going to have a positive increase. The third characteristic will be carry positive. Well, what does carry positive means is that it really just means theta positive, which means that as the portfolio, as time increases, you can sit on the portfolio because the portfolio will naturally generate some return for you over time. And therefore, you can actually afford to wait for a long time for opportunities. This is in comparison to a carry negative portfolio where you will start to lose money as time go by. So and you for that kind of portfolio, you probably don't want to sit around for a long time, because the longer you sit on it, the longer for an opportunity to materialize, you will incur losses. So carry positive is very important. That allows you to wait for the opportunity to materialize, because a lot of time you may believe there's an opportunity, or there may be a possibility, but you sometimes not able to have a very good grasp of when that opportunity may materialize. So if you have a carry positive portfolio, you can afford to wait. And finally, typically people want to have a very small net funding. So you don't want to put in a very small, a large amount of initial investment. This is related to leverage. So the smaller, for the same amount of dollar value returns, the smaller the initial investment, the bigger is the return in percentage. And therefore, there's a bigger leverage there. So if you can have a high leverage, it's actually important because it increases the efficiency for return generation. However, high leverage also is risky as well because you can get wiped out very easily. Now, so typically if you work in the financial industry, work in the investment industry, people want to have those characteristics of the portfolio. But you will see that actually you can't really have all 5 things simultaneously. Let's take a look at why this is the case under the Black-Scholes Merton framework. So take the simple case where the underlying stock is not paying dividends. Then we have this, again, the fundamental partial differential equation here. And if you look at it, we mentioned that it's really just the theta times RS times the delta times plus half of gamma times sigma square S square. And this is equal to R times the value of the current value of the portfolio. Now, in the Black-Scholes Merton framework, we can rewrite it this way. And for a delta neutral portfolio, means that this delta is equal to 0. So this term dropped out. Okay. So we have theta plus half of the gamma times sigma square R square equal to R times the value of the portfolio. Now, a high leverage portfolio means this pi value is very small. So this is close to 0. And then you cannot have a carry positive and a large carry positive and a very good gamma positive portfolio. Because if this is very close to 0, and if this is large positive, this will probably be negative. And if this is positive and large, this value will probably gonna be negative. So we mentioned that a negative theta is not really good because that means you cannot afford to wait very long. And at the same time, a negative gamma is not good for the portfolio as well. So graphically, you can see on the left-hand side, this is a positive gamma portfolio, which means that as the underlying assets is moving, increase or decrease in value, the portfolio value will always increase, no matter which way it goes. Whereas for a negative gamma portfolio, the portfolio value will always decrease, no matter which direction the underlying asset is changing. So which is undesirable. But as the condition here shows that you can have all 5 things together. So if you have delta neutral and a high leverage, then it's very easy to have one of them either carry or gamma be negative, unless they're very, very small. So if then you have, carry is almost nothing, so you wait, but it's not generating any value, and then your gamma is close to 0. So basically, if you don't have anything, you don't have any, there's nothing that you need to worry about for theta, nothing you need to worry about for gamma. But if you want to have good characteristics, then you really want to have large and positive theta here. You want to have a big carry that as you sit on the portfolio, you actually naturally making returns. But if you have that, you will then have your gamma being negative, which is actually undesirable. So one way or the other, there is some undesirable aspect that you cannot really avoid.